Okay, let's unpack this. Welcome, everyone, to a deep dive into, well, a really mind-bending idea from the source material today.
It really is.
We're looking at materials and motion, specifically through this lens the source calls motion theory.
And the thing that grabs you right away, it's genuinely counterintuitive, is this argument that as our materials get better, more advanced plastics, metals, composites, we actually become less aware, kind of less sensitive to the motion that's fundamental to them.
Right. It feels completely backward. You build this super stable, seemingly static world. And the source argues that by doing that, we've made ourselves, quote, motion deaf.
Exactly.
So our mission for this deep dive is really to get into that idea.
Yeah.
Why does the source claim this, using only the material we've got here as our guide?
Because, well, the source's starting point is that reality is motion. Everything's built from these structured, synchronized loops, always adapting.
Constant rhythm.
Constant rhythm. But our daily experience, it just screams stillness,
Right.
right? So why the disconnect?
Well, that's the first big point the source makes. It says we've engineered an illusion of stillness on purpose, almost.
How so?
We pick these advanced materials because they hide that rhythmic nature. They create surfaces that feel fixed, unchanging.
Yeah, think about the contrast the source draws. Look at nature. Trees sway, water flows, ripples. Even your own skin flexes, it responds.
Nature used to constantly show you motion. It was right there, visible.
But then you step into a modern building, a modern city, steel, plastic, concrete everywhere. The source calls them frictionless shells.
Mute armor. I like that one.
Yeah. They've replaced materials that were, feedback rich, things that showed you how they were reacting.
The source gets pretty specific, too.
Yeah.
It says steel has its synchrony law tight.
Right. Plastic, its motion is damped down, muffled.
And concrete. Just zero visible rhythm, no give, no flex you can see.
So the consequence, the source argues, is actually pretty straightforward, maybe even obvious once you see it.
Which is?
We coated over the motion, we covered it up, and then, well, we forgot it was there.
Like painting over a vibrant pattern and then saying the wall was always blank?
Exactly. Which leads to the next puzzle the source tackles.
Oh.
Okay, if everything is motion, why does saying that sound so abstract, so philosophical today?
Yeah, why doesn't it feel like a literal truth?
Because, the source suggests, we grow up surrounded by these dead surfaces. Kids today, they don't constantly interact with materials that visibly react, that show their internal dynamics when you touch them or put pressure on them.
The examples are good, like a touch screen. It's just a hard surface, right? It doesn't vibrate or slightly change shape to give you feedback about its inner structure.
Or sidewalks. They don't, visibly ripple or compress when you walk on them.
Even chairs often feel totally rigid.
Yeah.
They don't communicate that subtle shifting of the material underneath you.
The motion is definitely still happening. The source is very clear about that, deep down, atom by atom.
But the surface we touch and see, it gives us absolutely zero information about that. No feedback.
And that lack of feedback just powerfully reinforces the feeling, the illusion of stillness.
And the source keeps hammering this point. It's not a metaphor. It's literal. Our world is just designed, maybe accidentally, to hide the evidence.
Okay, but then the source takes this really interesting turn. It says, all right, let's zoom way, way in, down to the atomic level.
Right.
Even the hardest stuff, the most solid-seeming materials, are fundamentally built from atoms and molecules that are vibrating constantly.
Their hardness isn't stillness. The source calls it hyperstability.
Exactly. And maybe the wildest part is, even near absolute zero, things don't fully stop. There's still quantum motion. The source mentions things like positional uncertainty, zero-point energy.
And these tunnelable probability loops.
Where particles can sort of jump.
Yeah, seem to move without crossing the space. It's weird, but it's motion. And the source uses graphene as this amazing example.
Right, the super material.
It says electrons in graphene act like they're massless, not because they are, but because they hit this perfect loop sync. Perfect loop sync. What does it actually mean?
Well, the source seems to imply their internal motion, their rhythms, are so perfectly synchronized across the whole sheet that they just glide like waves. No resistance from the structure itself.
And it gets even stranger.
Apparently. The source talks about electrons flowing almost like a liquid in graphene, forming tiny vortices, streamlines.
Like water. Electrons.
Yeah, and it puts this down to entangled motion loops, like their individual rhythms are linked up, coordinated over distances.
So traditional physics might just call that weird quantum behavior.
Right, but motion theory, as the source presents it, sees it differently. It's not weirdness, it's structured motion unchained. It's rhythm in its purest form, not some mystery.
Okay, so to really make this point stick, that hardness is locked, motion, the source zooms in on diamond.
Perfect example. Looks totally still, totally clear. Hardest natural thing there is.
But the source says its structure isn't motionless at all. It's perfect carbon atoms locked in these ultra-high frequency loops.
And its strength. It's not stillness, it's sync density. The motion loops are packed incredibly tight, synchronized with amazing precision.
So to break it, you need to basically cause a catastrophic failure of that sync.
Exactly, it has to collapse. And the source suggests this idea applies more broadly to tooth enamel, crystals, pearls.
Even synthetic polymers, strong plastics.
Yeah, it sees them all as kinds of loop-stable rhythm cages, structures that contain and synchronize motion to appear rigid.
And you kind of feel this, the source implies, when you try to break something really hard.
Right. It doesn't usually bend slowly. It either resists completely, just absorbs the force.
Or it shatters instantly. The whole sync just goes.
Which, if you want a really dramatic visual for this hidden motion and how fragile that sync can be, the source brings up the Prince Rupert's drop.
Ah, yes. Those bizarre glass tadpole things.
Yeah, where the bulb end is incredibly strong, right? You can hit it with a hammer, supposedly.
Because the outside cooled super fast, compressing the inside.
Right, massive internal stress.
Right.
But the tail...
The tiny little tail. You just snap that.
And boom, the whole thing explodes, just vanishes into powder. It's incredibly dramatic.
So why does that happen, according to the source?
It says the drop is basically stored tension. Or, put another way, frozen structured motion loops locked into a delicate sync. All that rapid cooling trapped this immense potential energy, this organized stress.
So cracking the tail isn't just breaking glass.
No, the source calls it triggering one desync at the edge, just one tiny break in the pattern.
And it cascades.
Instantly, through the whole thing, all those tightly wound, interconnected motion loops just unravel explosively.
The source reframes it. It's not glass cracking, it's motion unraveling. Wow.
Which brings us right back around, doesn't it, to the starting point and the source's main conclusion.
Yeah. The more rigid, the more uniform, the more industrial our built world becomes.
The more we, quote, kill the feedback, we get rid of the signs, the visible, the tangible evidence of that fundamental motion.
But the motion itself hasn't stopped. It's still there. Vibrating, spinning, resonating under the surface of everything.
But our civilization, our modern way of seeing things, has sort of collectively forgotten this reality.
It's why if you adopt this viewpoint and say, hey, everything is motion, the normal reaction is, what? No, it's not. Look at this table. It's solid.
But from this motion theory perspective in the source, that table isn't still.
It's locked motion.
Exactly.
Yeah.
The illusion of stability we see is just maximum synchronization at the molecular scale. It gives the appearance of being static and hard.
So what does this mean for you listening right now, sitting there maybe looking at your desk or your phone?
Well, the source finishes with a pretty powerful idea. It says we need to go beyond just knowing this intellectually. We need to start feeling motion again in our everyday lives.
What does it suggest?
Simple things, actually, like feel the wind push against your shirt. That's your surface for a moment, syncing up with these huge atmospheric loops of motion.
Okay. Or touch wood.
Yeah, touch a piece of wood and know it's subtly flexing, breathing, it's syncing slowly with the moisture loops, the temperature loops in the air.
Watch a flame. The source says, see it as energy looking for loop resolution.
Right. Not just burning, but this intense kind of chaotic energy trying desperately to find a stable, synchronized state, a pattern.
There's a warning in here too, isn't there, about forgetting this?
A pretty stark one. The source suggests we risk mistaking silence for truth, and maybe stillness for death, if we only pay attention to the rigid surface and ignore the vibrant motion underneath.
Because ultimately, based on the source material we've explored, even the hardest object is just motion held together by agreement.
Agreement among all those tiny synchronized loops, it seems.
Yeah.
Yeah, it's a perspective that really does challenge how you see the solid world around you.
It absolutely makes you look at that table differently, doesn't it? So thinking about this deep dive, here's a final thought for you, the listener, to maybe chew on. How might really taking in this idea of hidden locked motion change how you look at, how you touch, how you interact with the seemingly solid things in your life from now on? What subtle rhythms, what suppressed motions might you start to notice just under the surface?